Hello everyone, my name is Sahil and this is the video representation of that application, Android application. So I have extended two of the functionalities, that is Edgy and Best Line. So first I'll go through the Edgy and then the Best Lines. So in this algorithm, I have first converted the RGB image to a grayscale image, and then to make the computation easy, I have converted a matrix to a Java array. And for that, first we need to convert the mat into a 16 cv underscore 16 uci that enables us to use a short data type for a Java array. And this is basically the conversion to array is to make the processing faster. And then this gets the pixel values, and same for the result. So I have two arrays, that is GA and CA. So GA is for the grayscale image that we are getting into an array, and then CA array is to store the result. So we got the width and height of a image, and then we also get the channels. Channels is basically for gray, the channel is 1. If it's RGB, the channel is 3. So now we we iterate through every pixel of the image, and then uh, try to convert the image into the Laplacian image. So for every row and column of height and width, it goes to a Laplacian function, and the Laplacian function looks like this. Oops. Sorry. So this is the gray total that will be returning. This is basically a double data type. So the kernel size is 3 by 3, and then the kernel is reduced to half, so that we get a variable gray total that has a double value. It's basically an integer value of double. So we return that gray total to back to our edgy function. And then if this is the threshold value 230, so we are thresholding an image. So if the value of the Laplacian image is greater than 230, then we set the channels we set the result array as following. So 255 is for basically red, to display the red lines in the images, and rest is set to 0, that is G, B and A. And then after once the for loop is executed, both the for loops are executed, we again put back the pixel values of an image so that we can return it to our Android front view. And so yeah, this is it. This is the edgy one. And now we'll talk about the best lines. So the best lines algorithm is kind of similar. So it has initially we have converted the image to from RGB to grayscale, and then we converted the mat to array for the faster processing, and then the filter size we have taken is 3 by 3, and the result is used to store the result. This total is basically the double value of a 1D, all the pixels in a 1D array. So after a Laplacian filter, after applying a Laplacian filter, we store all the values to this data double data type folder. I mean variable total. So for this multiple nested for loops is basically multiplying the filter and storing it into a 2D result. And if the value of this result is less than 0, then it is set to 0. And then if it's greater than 255, then it's set to 255. Okay, so and then next is the so this nested for loop is basically to convert the 2D array that we had earlier, that is result, into a 1D array of temp. so that we get a single dimensional array. Then so next is we process the image and through a canny edge detection that we already used earlier. So this helps canny edge detection helps you find the edges in the image, and then later we can convert this later we can convert the canny edge detected image to BGR. The BGR is basically to display the blue, green, and red of the lines. That is, will be using blue and red. So we convert it to the BGR format, and then we make initialize a new matrix to store the result, and then we get the width and height of the image matrix to use, and we'll be using the width and height will be determining the threshold value, such that the threshold value is 1/4 of the original I mean the size of the image. And then we can as per the constraint given, we can use the half lines function to detect the lines, and then to draw the lines first we have to calculate the slope of the image, and after calculating the slope of the image we also calculate the angle of an image using tan function. And the angle is basically the angle of a straight line, and if the angle is in between 0 degree to 30 degree, we draw the red lines, that is the best top 10 red lines. And if the else if the angle is more than 30 or the count is more than 10, we draw the blue line. So this part of the code basically explains the slope and the tan that we have used for the angle. So this is for drawing the lines. And to calculate the slope, we have simple formula. We have used this simple formula y2 minus y1 upon x2 minus x1, that is stored in S, and then this slope is again passed to the mat function to calculate the angle. So using the slope, we calculate the angle of the angle of the image using tan. And then if the angle is less than 30, then we draw, and if count is less than 10, then we draw red lines, that is image proc lines. And this 25500 is basically for red, and we draw red lines on the image. And then else if the value of tan is greater than 30, or it's the count is greater than 10, we draw the blue lines. And after at the end, after all both the for loop have been executed, we return the image. And this image is basically displays all the baselines, that is between angles 0 and 30 in red, and the rest of the images are displayed in blue. So this is it about the best lines and edgy. Thank you.